Hello guys, welcome to the 5th episode of the Ethernaut challenge. In this challenge, we are given 20 tokens and we were asked to beat the level by getting more than 20 tokens. And this is just the method we need here. This is the transfer method. And this is what brings us to underflow and overflow. So they say we should look at odometer, and I have an image here that best describes this. So this is an odometer. It starts from 0, right, and it goes 1 to 9. Since it's a single digit, it can't take 10, so it has to take 1 to 9. So once it reaches 99999, the next value will reset everything back to zeros, which is what happens here. Everything resets back to 0, and if we should subtract 1 from this, everything will reset back to 9999. So this is what overflow and underflow is. This is the highest it can get. So once you add 1 to this, it starts from the beginning, the minimum, which is zeros, and this is the lowest it can get. Once you subtract from this, it starts from the maximum. So I've recreated this project, this smart contract, which is here. So this is just a smart contract with the mapping, address that points to uint, a constructor that initializes us with 20, and this is the transfer method. Okay, so if we should deploy this contract, the first error in this smart contract is this require statement. So I'll wrap this in a parenthesis. And because of underflow, since we have 20, if the user should specify a value greater than 20, maybe specify 21, this will revert to an underflow, and this value will become greater than 0. So no matter the value the user inputs, this require statement will always be true. And next is the balance. So since the user has 20 balance and the minimum uint can hold is 0, if you minus 21 from 20, you've exceeded the minimum. The balance of this user will be the maximum of the uint. So to see this, I will copy an address that is not the same address that you're trying to gain. So I'll use this other address, copy this address and paste it here, and I'll paste 21 or any value greater than what you have, and I'll switch back, and I can check my balance before we start this. And if you check my balance, you can see it's 20. It's 20. So once we transfer this fund and we check the balance, you can see we have this huge number. This is the maximum that the uint data type can hold. So what happened there was an underflow. So we have to do the same thing for this variable, and this is it. The address doesn't have to be mine, so I'll copy an address that's not mine, and let's copy this and paste it here. Okay, but before we do this, let's check my balance. And as we can see, we have 20. Yeah, 20. So now we can call the transfer method passing an address that is not ours, because if you pass in your address here, once it reaches this place, once it adds it up, it comes back into an overflow, and the value will be the same value you started with, which is still 20. So we don't want that, so we'll put in an address that's not ours. And once we run this, okay, now we'll wait for the transaction to be mined. Okay, the transaction has been mined. And if we should check our balance, hopefully we've hacked this contract. Okay, I'm saying, yes, you can see we have huge number of tokens from this contract. We can check it using number. I can typecast this to a number. Okay, let's just do this way. Okay, what's wrong? I can typecast this to a number by doing this. And as you can see, we have this here, exponent of 77. So we have a very rich token right now. We can submit this instance. So this has been completed, and yeah, you can use the safe math library. This is the OpenZeppelin, the guys that created this game. This is the OpenZeppelin library. They have the overflow and underflow code in it, so you just have to use the library to work with your smart contract. So that's all for this video. In the next video, we'll talk about delegate calls. So thank you guys for watching, and I'll see you in the next video.